In this lecture, uh, we will study about a special function which will be dealt by using logarithm. So let us start. When a function y is equal to f of x is one of the following forms. Number one, if a function to you people is in the form variable to the power variable, you may say that x to the power x, you may say that cos of x to the power log of x. So x is a variable, so if the base contains the variable and the power also contains the variable for this kind of function, and secondly, if a function contains all the three basic rules, that is power rule, product rule and quotient rule, or if you think that a function is complicated enough to differentiate directly. So in all these three cases, what should we do? We should take natural log on both sides and differentiate with respect to x. That is not necessary that you take natural log. You can take log to the base some other number, but natural log is simple to deal. So that's why take natural log on both sides and then differentiate with respect to x. Secondly, multiply both sides by y, and then the last step is replace y by its own value to get the required answer. So remember that if the function is in this form, or the function contains all the three basic rules, and if you think that a function is complicated enough to differentiate directly, then in all these three cases we will follow these three steps, that we will take the log on both sides and using the properties of log function to simplify that difficult function, and then differentiate the given function with respect to x. Then multiply both sides by y, and the third step is replace y by its own value to get the desired answer. For example, in this slide, from question number 35 to 38, it says that find dy dx using logarithmic differentiation. So that is question number 35. We see that this is x into cube root of 1 plus x square. You can differentiate this function directly, but you are asked here to use the logarithmic differentiation. So we must take the log of both sides. You see, product rule is involved here, power rule is involved here, so that function is a bit difficult to differentiate directly. So taking natural log on both sides, so we have taken the natural log of y and natural log of this side. Now use the properties of log. Log of m into n is equal to log of m plus log of n, and then again the property of log, drop this power in front of the log, that is 1 by 3 natural log of 1 plus x square. So you see that we have simplified this function by using the log properties. This cannot be simplified more. So if this cannot be simplified more with the properties of log, so differentiate this function with respect to x from here. So whenever you differentiate this function, you'll get this equation: derivative of log of y is equal to derivative of natural log of x plus 1 by 3 natural log of 1 plus x square. Now from the left hand side we see that that is the derivative of log of u, and we know that derivative of log of u is 1 by u. Instead of u, y is here, so that is 1 by y into derivative of y, further derivative of y, and that is the sum rule. so multiply d dx inside, just like in this fashion. Now we see that the derivative of log of x is 1 by x, and the derivative of log of u is 1 by u into derivative of this u again, further derivative of this u, 1 plus x square. Now simple, find this derivative. Derivative of 1 plus x square, derivative of 1 is 0, and derivative of x square is 2x. So we are going to multiply both sides by y because y is here. We need to find dy dx. So in order to find dy dx, we need to multiply y from both sides. So multiply y here, that will be cancelled out, and you'll get only dy dx this side, and this y will be multiplied with this whole side. So you see, y is multiplied with this whole side, and we have applied this derivative within these brackets. Derivative of 1 is 0, and derivative of x square is 2x. Now 2x into 1 is 2x, that is dy dx. Now the third step is we need to replace this y by its own value. What is the value of y? That is the value of y, the given question. So put the value of y here. We'll get dy dx is equal to, this is y, this whole is y, and that is inside the brackets. So that is how we find the derivative of this function by using the logarithmic differentiation. That is very much important questions. In fact, questions from 35 to 38 are very important questions. So you need to solve each and every question, and if there is any difficulty, so contact as soon as possible. Now in the next slide, in this slide we see that question number 39 and 40 are same. What is question number 39 and what is question number 40? There is a note which is the property of a logarithmic function. Log to the base ae, log to the base ae, when you take the reciprocal of this function, that will become 1 divided by log to the base ea. What does it mean? It means that this base and this value will be interchanged when we take the reciprocal of this log. That is, these two will be interchanged. So this log to the base ae is equal to 1 divided by log to the base e, and that is a. And log to the base e is actually natural log, so you can write this as 1 by natural log of a. So that is the property of logarithmic function as well. Question number 39, it says that find the derivative of log to the base xe. So we see that the base of this log is a variable, and this e is actually a constant number. So how could we deal this kind of function? We need to interchange these two numbers. How could we interchange these two numbers? By using this property. So we can first of all denote this function without this derivative. Denote this function by y, then take the reciprocal and interchange these two, so that will become log to the base ex. But we know that log to the base e is actually natural log, so that can be written as natural log ln of x. So that is 1 by log of x, and when we shift this log of x towards numerator, so that will become log of x whole inverse. So that is y is actually natural log of x whole inverse. Now we need to find the derivative of this function, so it means that we need to find the derivative of y. So differentiate with respect to x both sides, so you'll get dy dx that side and d dx of log of x whole inverse towards that side. Now that is actually derivative of u whole inverse. Extended power rule is here. So dropping this -1 in the front of this log of x and subtracting 1 from the power and to further derivative of log of x. And now we see that log of x -1 is actually log of -2, and derivative of log of x is 1 by x. That is 1 by x. Now we see that the power of log of x is negative, so shifting this functions towards denominator, that will become log of x whole square. You see, that is log of x whole square along with this negative sign. So that is the derivative of y, and y is actually this function. So that is the derivative of this function. So that is question number 39a part. Now we see that we need to find the derivative of this function. So deal this question in this fashion. First of all, we need to denote this function by y. Now the base of log is actually a variable, so interchanging these two by taking the reciprocal, that will become log to the base 2x. Now log to the base 2 is not a natural logarithm, so you cannot write this function in the form of ln. So that is log to the base 2x. Shifting this function towards numerator, so that will become log to the base 2x whole inverse. Now you need to find the derivative of this function, in fact the derivative of y. So differentiate with respect to x both sides. You'll get dy dx is equal to derivative of this function. This is actually extended power rule, so apply the extended power rule here. So that will become just like this function, -1 log to the base 2x -1 into further derivative of log to the base 2x. You see that this is actually general logarithm. The base is not e, so apply the formula for the derivative of general logarithmic function. So that will become just like 1 by x natural log of the base, natural log of these two. So that is the derivative of this function. But we see that the power of this function is negative, so shift this function towards denominator, we will get the answer for dy dx. So that is the whole answer of this question. You can deal question number 40 in this fashion. So solve question number 40, and then if there is any issue, so you can contact. In this slide we are going to discuss some special things about the logarithmic function. You see that if the base and this value are same, log to the base AA, it means that log to the base 10, log to the base EE, if these two are same, so the answer will always be equal to 1. You see, log to the base AA is 1, log to the base 10 is 1, log to the base EE is 1. But if the base and that value are not matching, then this answer will not be equal to 1. So remember this property. And secondly, we have discussed this topic in the previous lectures, but I'm going to repeat this topic in this lecture. Equation of tangent line to a curve y is equal to f of x at a certain point x naught y naught is y minus y naught is equal to m times x minus x naught. That is the equation of a line actually, but that is the equation of a tangent line. In this equation you see that we need x naught and y naught and m as well. X naught will be given to you people, y naught will also be given to you, but if y naught is not given to you, put the value of x in the given equation to get the value of y naught. So these two will be given to you people, or only x naught will be given to you people. You need to find y naught. And secondly, m will be obtained. m is the slope of tangent line actually, and m is the derivative of the given function with respect to x. The derivative of the function with respect to x, that is actually the slope of tangent line. We need to put the value of x naught, and if there is y naught, so put the value of x naught and y naught in derivative to get the value of m, and finally put the values of x naught and y naught and m in this equation to get the equation of tangent line. So that is actually question number 41 to 44 regarding the equation of tangent lines. So question number 41 through 44, we are asked to find the equation of tangent line to the graph of a function at a certain value of x naught. Question number 41, the function is given to you which is log of x, and the value of x naught is given to you which is e power minus 1. So you see that x naught is given to you people, y naught is not given to you people. So first of all we need to find y naught. Let us denote f of x by y, because we know that y is the function of x. So denoting this function of x by y, so y is equal to actually log of x. Put x equal to e power minus 1 in this equation to get y. So put x equal to e power minus 1 here. You'll get y is equal to log of e power minus 1, and using the property of log function, dropping this minus 1 sign in front of log, so that is actually minus 1 log of e. We know that this ln is natural log and the base of natural log is e, so this log is actually log to the base e, and from above we see that log to the base e is equal to 1. So natural log of e is equal to 1. Minus 1 to 1 is minus 1, so that is the value of y, and this is the value of x. So the point x naught y naught is now x naught is e power minus 1, and y naught is actually this value of y which is minus 1. So we have obtained the value of y naught which is minus 1. Now we are in search of this m, and m is actually the derivative of y. M is the derivative of y. So find the derivative of y from here. Differentiate equation number 1 with respect to x, both sides. So derivative of y is equal to derivative of log of x, you see here. So and derivative of log of x is actually 1 by x, that is the derivative of y. We need to find this derivative at this given point, and we see that only x is using here, so we just need to use the value of x, in fact the value of x naught. So put x naught equal to e power minus 1, or we may say that put x equal to e power minus 1 in this equation. So dy dx is equal to 1 by x, 1 by e inverse, and that is actually inverse, so shifting it towards numerator to get e. So dy dx is equal to e, but we know that dy dx is m, so m is equal to e. Dy dx is m, so m is equal to e. Now equation of tangent is y minus y naught is equal to m into x minus x naught from here. Now putting the values of x naught, m and y naught in this equation. Y naught is minus 1 from here, y is minus 1, that is the value of y naught, so that is minus 1. M is e from here, and x naught is e power minus 1 from there. And now simplify this equation, minus minus plus, multiply e inside, so that will become ex minus, that is e and that is e inverse, so that will be equal to e power 0, and e power 0 is 1. And shifting this one towards right side, that will become minus 1, minus 1 is equal to minus 2. So y is equal to ex minus 2 is the equation of tangent line. So that is the criteria to find the equation of a tangent line by using this equation of a line. So I hope that this topic is will be clear to you people. If there is any question, so you can ask afterwards.